All right, back in chapter 1, we studied what we called univariate data, your test scores. We took all your test scores and we drew a picture of them. We drew box plots and histograms and so on. And then we talked about them, center, shape, spread, and outliers. All right, in this chapter we're going to discuss something called bivariate data, bi meaning two. So for the same individual, could be a person or whatever, we're going to look at two things at the same time. What are we going to do? We're going to graph it, and we're going to make observations about what we see from the graph. Okay. This is an example right here. Let's say, and every year I wish I'd do this, let's say I would have asked you how many minutes did you study for a test? And then later I recorded what your grade was. Now both of these scores go with this person, okay, this individual, and then I've got 10 different scores here. Wouldn't it be nice if I could do something, manipulate this, and then be able to predict the future? So come up with some sort of I don't know, mathematical model for this, and then you ask me before the last test, hey, I'm planning on studying about an hour tonight. What do you think my grade will be? I could predict the future for you. And that's what statistics is all about. Taking a small number of items and predict it for everybody. Okay, bivariate data. Now, statisticians, we got to be different, right? We can't have the same names as everybody else. You guys have used these before. You've done this before. Back in Algebra 1, you called these points X and Y, didn't you? And you graphed them on an XY plot. Then you got fancy. They gave it names. They called it the independent and dependent variable. Remember why they did that? Remember you guys had to do a bunch of these, right? Your X and Y charts. Right? You had some equation. I don't know. Y is equal to 2x plus 5. And then you would plug in a number. 3. You plug that in there and it came out 11. Okay, then you plugged in 10. Popped out a 25. Now, why was this called the independent? Why was this called the dependent? Well, you can plug in anything you want, right? You're choosing what to plug in. But then based on what you plugged in, these numbers were dependent on what came out. So that's why you call them the independent and dependent variable. Well, we got different names for them. We don't call them that here either. All right, we call the x value, the independent, the explanatory variable. And then what comes out is the response variable. Now sometimes it's obvious which one you should set up as the explanatory and response. I mean, it makes sense here, right? You choose how many minutes you study. Okay, that's independent. You choose what that happens. Then dependent on this, that helps determine your grade. But sometimes it's not so obvious. If your two variables were SAT math and SAT verbal, like, which one do I put which where? I don't know. But sometimes it's pretty obvious which one you put in as the explanatory and which one you put in as response. All right, you've done this a million times. Graph this. Go, right now. It's called a scatter plot, but you've done this a million times. I want you to graph these points. Okay, go ahead and do it. Make a graph. How you would do that. Go back to Algebra 1. You're graphing these points. 45, 76, 47, 78. Graph it. All right, I'm seeing some good stuff out there. If I were you, going back to Algebra 1, I had to graph these, I would do this. And a lot of you did that. Right? Isn't that how we graph stuff back in the day? But some of you noticed, hey, these are all positive numbers. So some of you just drew this part, which I think is a great idea. Now, there could be negative numbers here, so don't forget about this thing. Okay, we might have a graph that looks like that, but I think we just probably need to show the first quadrant in here. All right, on your paper now, so this is the explanatory variable. It goes down here, goes with the x's. This is actually in this problem minutes studied. I don't know, what do we got? Kind of a wide range here, right? 0 to 126. I've got to fit them all in, which guys goes by tens, probably. Okay. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and 130. All right, the response variable, okay, we're going to call the grade on the test. Now here you've got some options. Now I think most of you probably went from 0 to 80, but your graph was, kind of just always up here, wasn't it? So if you wanted to fill up your whole graph, you could do one of these guys, you know, and then start at 30. And that would fill up your whole graph with stuff. Either way, it's not wrong to go from 0 to 80 on this one. But if these numbers were all from, I don't know, 340 to 350, don't start at 0 and put all those numbers up there. Spread it out on your graph a little bit. So I don't know, I'll do it this way. 30, 40, 50, 60, 70, and 80. And now we just plot our points. 45, 76, 40, 47, 78, 40, 70, 126, 79, 642, 1432, 2061, 040, 2566, and 1050. I had a great question. Somebody last period said, "Hey, I sorted them, and my graph came out different." Of course, I never had been asked that question before. I said, "No, it won't. No, it won't." Wait a minute. Will it? Will the graph come out different if you sort these numbers? Well, yeah, because I need to keep this 40 and 70 together, right? This is the same person. I can't have the 40 go into a different test score. It's going to mess everything up. Okay, so you don't sort them, okay? Keep them together when you're making these plots. All right, so on one of your homework problems tonight, you're going to have to do a graph by hand. But after that, we're going to let our calculator do it for us and then put it on our paper. All right, so let's show you how we do it on the calculator. All right, just get rid of these ugly looking things. All right, first of all, turn all your plots off. I have a lot of you come up to me, "Hey, I got this weird error." It's because you got another plot on. Make sure you're going to y equals, make sure you got no equations in there. I've been working with some of you, got some crazy equations in there, and then your graph doesn't work, so clean everything out in there. All right, so let's go into the first plot, turn it on, and then this guy right there, that's the scatter plot. Now notice it's going to ask for two different sets of data now. Well, that makes sense, right? Because we got them in L1, L2, so go down there and do L1, L2, and then make sure you go down to the bottom, and there's three different kinds of dots you can make. You can do any one you want. All right, now our job, just like we do with the box plots, is we need to set up our window. So go set your window up like you have it set up. For mine, so I go into Window. I started my explanatory variable at 0. It went to 130. I went by tens. And then my y values, I actually started, I don't know how I did that. It kind of looks like 20. So I'll just say I started at 20 and I went to 80 by tens. Set yours up how yours was, however you did yours. So if you went from 0 to 80. And then just hit the graph key on the far right. And it should look exactly the same. Okay. All right, now another interesting key, and this is one you're going to use a lot, is zoom stat. All right, remember what zoom stat does? It's going to set the window up like it wants to. So if I do zoom and then down to stat, the graph looks kind of the same. But now in order for you to set these up, go to your window and notice how they changed them. They started at, negative 12 and went to 138 and so on. Okay, so zoom stat's a nice, quick, dirty way to do it. You don't have to worry about the window, but then you're going to have to go in and make sure you put the relevant numbers on your picture. Okay, like I said, tonight you'll have one you do by hand and one you do with your calculator and then put it on your paper. But, just like in Chapter 1, it wasn't about drawing the picture, it's about doing some analysis of that picture. So what are we looking for? All right, first thing we always do if we're given some bivariate data, we want to plot it. It's called a scatter plot. And then we may want to add some numerical summaries. Like I may want to find out the mean and standard deviation of how long people studied and the mean and standard deviation of the test scores separately. I may want to go through some of that analysis. But these are the big guys, okay? We want to look for an overall patterns or deviations from the patterns. Now, what do I mean by that? First thing, you want to look to see if your graph either has a positive association, a negative association, or no association. And this has like a rough, loose slope kind of thing. You guys remember a positive slope? It went that way. But what made a positive slope? As the x got bigger, the y got bigger. Okay, so that resulted in a positive slope. Negative slope, that was when the x got bigger but the y got smaller. It would cause you to have a negative slope. Now, same idea here. A positive association are when the points are going up this way. A negative association if the points are going down this way. And no association, it's kind of like a circle. And I can't tell where it's going. It kind of has a zero slope to it. Alright, so what would you say here in terms of direction for our minutes studied versus, oh yeah, don't forget you'd have a title here. Comparison of minutes studied test grade. So what would you say in terms of the direction of this particular data? I agree. This one's going up, the other's going up. So we'd say that this graph has this data has a positive. That's a good thing for this, right? I'd hope the more you study, the better grades you get. Yeah?
Is that one dot an outlier?
Oh, we're going to talk about that. Okay. There a second. All right, the next things that I want you to look for, kind of like last chapter 1, I want you to look for clusters, gaps, and potential outliers. Clusters, I don't know if I see any real clusters here. Not really. I mean, a whole bunch of points kind of at the same spot. I mean, nah, I wouldn't even call any of these a cluster. Maybe you got a little cluster here, maybe. But how about gap? That's a huge gap. And what is that a gap in? Minute study. Now, if I had a point that was way up here, okay, I'd see a gap in the test grade. I guess if it was out here, I'd have a gap in both. So you would talk about that gap and what it refers to. And then finally, are there any outlier points? And here's how we define outlier here. And I don't have a fancy formula for you. It's, hey, do any of these points don't belong with the others? Okay. Do any points here, like what are you doing in this graph? That's an outlier. So would we suspect we possibly have an outlier here? Yeah, you bet. Do you have a question?
Yeah, so would you also say that there's a gap between the second and third data points? Is it like from point to point, or just kind of...
Second and third data points. What do you mean?
Or I guess it's the third and fourth. I forgot about the 40. I'm kind of tied in there. In the y direction, on the y-axis, there's a pretty big gap.
These two?
No, the top one and the one that's... 32, no, like the one you were pointing at.
No. Are you saying, wow, I see a gap between this one and this one?
No. I'm saying a gap between the third and fourth data points in that.
You gotta come show it.
Yeah.
Or third and fourth data point.
I'm saying, would you also say that there's a gap?
I got you.
There?
Okay. I would say no. You're saying that these two, in terms of minutes studied, are very close together. Yet there's a pretty big gap. You know what? Maybe. Okay, I don't think it's as obvious as this one, but I might bring that up. Yeah, there seems to be a bit of a gap there between those two. Yeah.
So if like the minutes studied were 50 and the grade was a 30, would that be an outlier?
Minutes studied were 50 and grade was a 30?
Yeah.
Would a point right there be an outlier?
Yeah.
It's just like you don't belong. Yeah, you probably don't belong with the pattern. What's going on?
I'm confused. There's no like right and wrong for the outlier. Can't you?
There's no formula for it.
Yeah. So wouldn't that one point wouldn't that be an outlier?
No way. I don't think so. It's with other points. You might say, well, geez, I see a pattern here. You're not in that pattern. It's not that big of a break. And like I said, would I bring up that gap? I don't think I would talk about it. I don't think that's as big a deal as I see right now. Okay, then from all of this we want to get to here, and this is our goal. Is there a pattern here? And better yet, if there's a pattern, can I come up with some sort of an equation for that pattern? And that's what we're going to be spending a lot of time on this chapter. So, I don't know, you guys said there's a positive association. Do you guys think we could come up with some sort of mathematical equation for this? And some of you guys are, the first two classes said the same thing, and I thought it was really smart. Well, what do you guys see any potential mathematical equation for this?
Square root.
Yeah, what class are you working square roots on?
I don't know, I came in 4th grade.
Oh, you're a 4th grade, don't you? Every period has said square root. And you remember that square root graph? Remember that old parent graph, square root? It kind of started here and it kind of went this way? Yeah. Maybe square root's a good predictor. And that would be great. If square root's a good predictor, you'd say, give me your minute studied, I'll throw it in the square root formula, and I'll be able to predict your grade for you if those points fall. So, there's a couple of things I want you to talk about here. Number one, do you see a pattern? And then how strong is that pattern? Now, I wouldn't say all of these are perfectly lined up in the square root pattern, so I would say that's, a moderate to high square root pattern. Okay. So these are the things that I'm going to want you to talk about on your homework tonight when they say describe. Now, remember I was just you've got to write center, shape, spread, outliers. And I'm not quite that way with this. I don't like these words, direction, form, strength. So you can just kind of write up, but you've got to hit all these different things. Tell me what the association is, positive or negative or no. Talk to me about any clusters or gaps that you see. If you want to use these as headers, that's fine too. But I'm not going to lose my mind. But make sure you hit it all. Alright, just going to hit this early. We're going to talk a lot about it later. Now careful. Just because you get some sort of great pattern, or you know there's a positive or negative association, don't leap to, wow, this must be causing this. Now, maybe minute studied is causing grade, I hope, but you got to be careful. There was a study done, and it did this. It went up to kids, and they said, well, how many cavities you got? 3. And then it did a reading test on them, and it judged their reading level. So they did it for a bunch of kids, and they found an incredible positive association. Very strong. So should parents just be shoving candy down their kid's throat and tell them not to brush anymore because they'll be better readers? Do you think that the cavities were the cause of the better reading? Well, you guys are shaking your head no. What do you think the cause was? What do you think the underlying cause was?
Let's say you can't determine it. Just
Okay. There kind of was one here. It makes sense to you, I think, when I bring it up. All right. It was how old they were. Aren't kids that are older have more cavities in general? And aren't they better readers? So just be careful. Don't fall off the map and start feeding your kids candy so their teeth rot out because you think you found a pattern. So just be careful. You might find a pattern, but it might not be the actual cause. Okay, we'll talk a lot more about that later. And then finally, the last thing is this is all quantitative data, right? These are real numbers. But you can actually show categories on the same scatter plot. Like, for example, let's say these were all the boys, and I got 2 more sets that were just the girls. How could we show those categories on your scatter plot? Ideas? How could we? Yeah.
different symbols.
Yeah, different symbols, different colors, right? In fact, I learned this morning. You guys are going to laugh, but you could do this on your calculator. I had no idea. How do you think you could do this on your calculator?
Change the symbol.
Yeah, so go put your numbers in L3, L4, open up that scatter plot for L3, L4, and then change the symbol on the bottom. And you'll see the different... So at the same graph, you can see how the boys are doing and how the girls are doing. And do an analysis on that. You can compare them all together, or you can compare each one separately. Okay? So tonight, you're going to be drawing some scatter plots. You're going to be doing some written analysis. It isn't going to be incredibly long. You don't know much about this yet. You're just kind of saying what you see. But I want you to hit these areas. Any questions?